Welcome back. In this mini lesson we will learn about the figure of merit, which is just a fancy name for computing efficiency. The major drawback of the Monte Carlo method is the computing cost, which is associated with the simulation in case we want to achieve a very good precision. That means very small standard deviation of the mean value that we calculate. So often we try to improve the computing efficiency, and we do that by employing the so-called variance reduction techniques. These are special techniques that can decrease the standard deviation of the mean value. At first we are going to learn about the general variance reduction techniques that could be applied to any Monte Carlo simulation. And these general variance reduction techniques, they always require that we have some beforehand knowledge about the solution. For instance, we know the solution to some precision already. So these techniques, they can use this knowledge in order to decrease the variance. However, it is very important to realize that these variance reduction techniques will also take some extra computing cost for themselves, right? In order to use the variance reduction technique, we need to spend some additional calculations. So we could imagine a scenario in which the variance reduction technique itself would take too big computing time, which would outweigh the computing time of the actual Monte Carlo simulation. So then even if the variance in the mean value of the result would decrease, it would not be very clear whether the actual computing efficiency would be improved. You need to remember that we can always decrease the standard deviation in the mean value simply by running the Monte Carlo simulation longer. We can simply collect more samples of the result that we are calculating. By this way we can reduce the variance as well. There will be, of course, the additional computing time to generating more samples. So using the variance reduction techniques really makes sense only when we are sure that they could improve the actual computing efficiency. So for this reason we need some simple way to evaluate the computing efficiency and to compare the efficiency of the standard Monte Carlo calculation to the calculation which uses the variance reduction technique. So we learned that the precision of our Monte Carlo simulation is given by the standard deviation of the mean value of the result. So I'm going to write it like this. The variance I'm going to write in terms of the standard deviation of the mean value. And we learned that this variance is proportional to 1 over n, where n is the number of samples that we collect. Now further we assume that the computing time is proportional to the number of samples that we collect during the simulation. So I can write that 1 over n is also proportional to 1 over t, where t is the computing time. So now I can write that the variance in the mean value equals some constant of proportionality divided by the computing time. Now c is constant during the simulation, so that means that the product of the variance of the mean value of the result and the computing time is constant as well. this product does not change during the Monte Carlo simulation. Now I'm going to introduce the figure of merit as the inverse value of this product. So that is 1 over the variance of the mean value times time. So because the product of the variance and the computing time is constant during normal Monte Carlo simulation, the inverse value of this product is constant as well. So the value of the figure of merit is a characteristic of the Monte Carlo simulation. It gives you the information to calculate the variance of the mean value of the result at a specific time. If you know the figure of merit, you can calculate, for instance, how much time you need to spend on the Monte Carlo simulation in order to achieve a specific variance or the standard deviation in the mean value. So let's take an example. Let's assume that it takes us the computing time 1 second to achieve the standard deviation in the mean value of 2. So this implies that the figure of merit of our calculation is 1 over 4. So that's 0.25. Now let's assume that we have implemented a variance reduction technique in our simulation, and we would sample the same number of values. So the n number would remain the same, but the variance reduction technique would take some additional time. So for the same number of samples, we could need, for instance, 4 seconds instead of 1 second, but the technique would manage to improve the standard deviation in the mean value of result. It would improve it from 2 to 1. So the figure of merit of such a simulation would be also 1 over 4, that means 0.25. That means you could achieve the same efficiency with the standard Monte Carlo simulation by just running it 4 times longer. Then the deviation would also decrease to 1 and it would achieve the same figure of merit. Let's assume a more optimistic case when the variance reduction technique is more efficient. So to achieve the same precision, it doesn't take 4 seconds but only 2 seconds, and it achieves the standard deviation of the mean value in the result of 1. So in this case, the figure of merit is increased to 0.5. So the figure of merit has improved. It has been increased twice, and that means the efficiency, the computing efficiency, is increased. So that is what we want. And let's take a pessimistic case as well, when the variance reduction technique is taking too much time. So for instance, it will take 5 seconds, although it will still improve the variance or the standard deviation in the mean value. It will achieve the value of 1. So in this case, the figure of merit is 0.2. So that means that the figure of merit in this case is smaller than the figure of merit of standard Monte Carlo simulation, where we don't use any variance reduction technique. So that means that during 5 seconds of the standard Monte Carlo simulation, we would actually achieve a smaller standard deviation in the mean value than 1. So in this case, it would not be a good idea to run the simulation with this variance reduction technique. It would be more sensible to run the standard Monte Carlo simulation longer. So the figure of merit is a very important quantity to us. It allows us to evaluate the computing efficiency. So we want to improve the computing efficiency, we want to increase the figure of merit as much as possible by using the best variance reduction techniques. So this is just a summary slide. I would like to warn you that the variance reduction technique that we are going to learn about, that they may improve the efficiency, but they may also degrade it. That depends very much on how you use these techniques. So in order to use them right, you need to know a lot, not only about the techniques themselves, but also about your specific problem that you are trying to solve. You need to have some information about the system and about the solution. If you do not have the correct information, you cannot trade it for reduction of the variance in the mean value. So it's possible that if you use the variance reduction techniques incorrectly, not only will they take the irrational computing time, but they will also increase the variance in the mean value. So the computing efficiency will get worse, the figure of merit will be decreased. So you need to use them wisely, and you need to know a lot about the problem you're trying to solve and the numerical model. That is all for now. Have a nice day.